Hello students, let us try to understand law of mass action. This is the next topic from the equilibrium chapter. Okay student, so let us try to understand. This law was proposed by C.M. Goldberg and that is Waage, P. Waage. So these two scientists proposed the law of mass action student. So what is meaning of the law of mass action student? This law gives the relation between the rate of chemical reaction and the concentration of the reactant. Okay, they are saying this law gives the relation between the rate of chemical reaction and the concentration of the reactant. So what is the relation student, about what this relation is given about? That is around the concentration. The first thing about the concentration they are giving about the concentration. Okay, and rate of reaction, rate of chemical reaction and the concentration of the reactants. Okay, this thing, concentration of the reactants. The rate of chemical reaction at a given temperature is directly proportional to the power of the active masses of the reactant at that instant. So that is what they are saying. That is, rate of chemical reaction is determined with the power of the active mass of the reactants. Power of the active mass of the reactant. This law is applicable to all reactants. This law is applicable to all reactions occurring in the gas phase or in the liquid phase. They are saying this law applicable to all the reactions occurring in the gaseous phase or in the liquid phase, not in the solid phase. Active mass or the molar concentration is indicated by a square bracket. So active mass is equal to molar concentration. Here it is represented in a square bracket equal to, that is, number of moles in volume in liter. This is what the active mass. Active mass of a gas is its partial pressure. Okay, active mass of a gas is its partial pressure. Active mass of the solid and pure liquid is taken as unity, that is 1. Okay, now let us have a look over the question student. 8.5 gram of ammonia is dissolved in 4 liter of aqueous solution. Calculate the active mass. Okay, so that is active mass. First of all, we have to calculate number of mole, given mass by equivalent mass. Given mass is there 8.5 gram, and molar mass of ammonia, how much is there student? Ammonia, that is 14 plus 3, that is 17. So given mass is 8.5 gram here, molar mass is 17 gram, number of mole is 0.5. Now active mass means what is student? Here they have given square bracket, that is n by number of mole of solute by volume in liter. So that is n by v in liter, that is 0.5 upon 4. It is coming 0.125 mole per liter. This is active mass. Let us have a look over the second question student. Which of the following is not a general characteristics of equilibria involving physical process? Okay, which of the following is not a general characteristics? Which of the following is not a general characteristics of equilibria involving the physical process? Okay, first option, equilibrium is a possible only in a closed system at a given temperature. Equilibrium is possible only in a closed system at a given temperature. All measurable properties of all the system remain constant. All the physical properties stop at the equilibrium. The opposing process occurs at the same rate, and there is dynamic but stable condition. And they are saying that is not general. Which of the following is not general characteristics of the equilibria involving the physical process? So this is the option number third. All the physical processes stop. This is not, sir, student. Dynamic means it is not that it is stopped. It will be dynamic means always continuously working. So here we can read out, at the stage of equilibrium involving physical process like the melting of ice and freezing of the water, etc. Process does not stop, but the opposing process, that is forward and reverse equation, occur with the same speed. Now students, let us see out the next one problem. What is the active mass of 1 liter of nitrogen gas as NTP? Okay, what is the active mass of nitrogen gas of 1 liter of nitrogen gas at ntp. So at ntp what is there, student? Volume of 1 liter, volume of 1 liter is how much, student? 22 point, volume of 1 mole is equal to 22.4 liter. Okay, volume of 1 mole is 22.4 liter. So at stp 22.4 liter of nitrogen is 1 mole. So active mass is equal to n by v. So 1 by 22.4 liter, that is 0.0446 mole per liter. So that is the active mass of 1 liter of nitrogen gas is 0.0446. So this is all about the law of mass action, student. Once more I am trying to explain you law of mass action. You try to understand, student. So law of no, this gives the relation between the rate of a chemical reaction and the concentration of the reactant. Rate of, what they are saying, relation between rate of chemical reaction and that is concentration of the reactant. Okay, another point they are saying, the rate of chemical reaction at a given temperature is directly proportional to the product of the active masses of the reactant at that instant. So this is all about the law of mass action, student. Thank you so much for watching, friends.